This video is regarding formwork and joints in construction technology module 5. The topic which we are going to discuss are about formwork, requirements of formwork, formwork for different structural members, classification based on materials used, and also joints in construction, that is construction joints, the various types, expansion joints and contraction joints. Let's see firstly about formwork. Concrete, being a plastic material in the green state, has to be kept within an enclosure till it gains strength. This temporary structure, which has to be built for any concrete member, is called formwork or shuttering. The materials commonly used are timber, plywood and steel, along with other materials such as aluminium, plastic, etc. Regarding requirements of formwork, it should be strong enough to resist the pressure or weight of the fresh concrete and also the superimposed loads due to the equipment, men, etc. if any. It should be rigid enough to retain the shape without undue deformation. It should not allow the cement paste to leak through the joint. It should not warp, bend or bulge. The inside surface of formwork should be smooth so as to give good appearance to the resulting concrete structure. Formwork should be made in such a way that it can be removed easily without causing the least injury to the surface or edges of the concrete structure. As formwork does not contribute anything to the stability of finished structure, it should therefore be made economical by reducing the cost through proper design, construction and use of formwork. Now let's see the formwork for different structural members. This is the picture of formwork for a simple footing, column footing. There are various types of forms used for column footings depending upon the size, shape and nature of column construction required. This figure shows the isometric view of formwork for typical rectangular or square shape. The box of required dimension is made from planks in such a way that the two ends are fixed by cleats. Suitable braces are provided to make the box rigid and strong. And to ensure further safety, the opposite panels are connected by tension wires before placing the concrete, and this wire will remain in concrete when the formwork is removed. Now regarding formwork for walls, here you could see various elements such as battens, the cleats, the braces, ties, studs, the veils and the sheetings. All these members assembled will form the wall formwork. Moving on to the formwork for columns, reinforced concrete column forms are subjected to lateral pressure because of the small cross section, large heights and relatively high rates of concrete placement. Thus, it is necessary to provide tight joints and strong support to the formwork. Rectangular and square column forms are usually made of wood, whereas round column forms are made of steel. Conventional formwork for columns is made of sheetings nailed together to form rigid sides. Here you could see the panels. And the column form sides are held together by yokes or clamps. Here you could see the various yokes. Moving on to the formwork for staircase. Here also you could see various members which are joined together. Here you can see the joist, the riser board, the riser cleat, strings, wall strings, etc. Next, moving on to the formwork for beam and slab. Beam formwork consists of open trough section and because it is not closed at the top, requires more supporting framework to restrain the sides. Beam forms must be shored up at frequent intervals to prevent sagging under the weight of fresh concrete. In monolithic construction, beams or girders and slabs are cast as single unit. The sheeting consists of plywood or timber planks. Here you could see the sheetings. The beam form is supported on head tree. Side forms are held in place by ledger strips. The vertical post or shows, braces, lateral supports, etc. provides a strong centering to beam and slab floor forms to bear all the loads acting upon it. Here you could see in picture the planks, the beam form, the slab form, the head tree, ledgers, braces and shorings. Based on the materials used, formworks are classified into the first one being wooden formworks. It consists of props, plank, battens, ledgers, sheetings, etc. It is the most common material used and hence called as traditional formwork. It can be easily be cut to size on site. Moving on to the plywood formwork. This is also one of the commonly used material and it is usually used for facing panel. It is easily cut to shape on site and if handled and stored carefully, it can be used a number of times. Standard plywood thickness is 18 mm. Initial cost of plywood formwork will be high. Next is the steel formwork. They are stronger and more durable and have longer life than timber formwork and their reuses are more in number. Steel forms can be installed and dismantled with greater ease and speed. The quality of exposed concrete surface by using steel forms is good and such surfaces need no further treatment. Steel formwork does not absorb moisture from concrete and hence it does not shrink or warp. So these are some of the advantages of steel formwork compared to the other two types, that is wooden and plywood formwork. Other than these materials, we also have aluminium formwork. It is often used in prefabricated formwork that is put together at site. Aluminium is strong and light and consequently fewer supports and ties are required. The lighter sections will deflect more, but this can be avoided by simply following manufacturer's recommendations. The last one being plastic formwork. Glass reinforced plastics, that is GRP, and vacuum formed plastics are used when complicated concrete shapes are required. Although vacuum formed plastics will need support, GRP can be fabricated with integral bearers, making it self-supporting. These formwork can be used or reused many times. Moving on to the next topic, that is joints in construction. The first one being construction joints. As it is not generally possible to place concrete in one operation, it is necessary to develop a suitable means to join the old and new concrete properly. So, construction joints are placed where they will cause minimum amount of weakness to the structure and where the shearing stresses and bending stresses are small, or where the joints will be supported by other members. These joints can be either vertical or horizontal as the case may be, and should not be inclined. The position and arrangement of all construction joints should be predetermined by the engineer. Consideration should be given to limiting the number of such joints. Here you could see a prepared joint surface and the reinforcement is continuing, which is shown by dotted lines. Next, the types of construction joint. We have butt type construction joint, tongue and groove construction joint, butt type construction joint with dowel, and butt type construction joint with tie bars. Let's see the first one, that is butt type construction joint. These joints are the simplest type of joints formed by the usual bulkhead board and are satisfactory for thin floors that are not heavily loaded. You could see the figure of butt type construction joint. And the next one is tongue and groove construction joint. It is usually provided in slabs. The keyway may be formed by fastening metal, wood or pre-molded key material to the wood bulkhead, and the second placing of concrete later enters the groove to form the tongue and thus allow for the shear stress to be transmitted through the joint. Next is butt type construction joint with dowel. This type of joint is done by just adding a metal or steel dowel in between the conventional butt joint. See, this is a figure of a butt type construction joint and you could see the dowels placed. The last one, butt type construction joint with tie bars. This is same as that of butt type construction joint with dowel, but the dowel used in this case is a tie bar. The tie bar is a deformed steel rod which increases the surface area, which in turn increases the friction between two concrete parts. Moving on to expansion joint. An expansion joint allows the concrete to expand or contract with daily temperature variations. Unless there is a provision for expansion, the concrete may buckle outwards and break. So we have to provide expansion joint, and an expansion joint is a gap in the building structure provided to allow for the movement of building due to temperature changes. These joints permit thermal contraction and expansion without inducing stresses into the elements. Joint fillers are used, which are usually bitumen felt, metal strips, fireboards, etc. Now you could see the figure of expansion joint with the joint filler placed in between. Last we have the contraction joints. A contraction joint or a control joint is a joint that is put in the concrete to control the cracking due to temperature change causing shrinkage of concrete. So construction joints are cuts or grooves made in concrete or asphalt at regular intervals. These joints are made at locations where there are chances of cracks or where the concentration of stresses are expected, so that when a concrete does crack, the location will be known to us. They are also known as pre-planned cracks, and they are made by saw cutting or tooling a joint in a concrete. This is the figure showing contraction joint. Thank you.